Please give him a big round of applause. Thank you.
Thank you. Namaste. Good almost evening. And first let me tell you that I'm very honored to be here in India. First time in India, first time in Asia actually, and first time as a speaker at a very important conference for Angular such as NG India. I'm going to talk about microfrontends, okay? I'm going to talk about module federation and the combination of module federation with Angular elements to solve a very particular use case that happened to me in my job. So, let's see. So this is the agenda. We will talk about some core principles and concepts, microfrontends, modules, module federation, and the user story that I'm talking about, what I am actually doing in my actual project. And finally, some demo code, so you can see how it works, and I can actually prove that it works, right? But first, let me introduce myself very briefly. My name is Andres, and I come from Madrid, Spain, but I have been living for some time already in Berlin, Germany. And I have been playing with Angular for a long time, so I love Angular pretty much. It's my favorite technology. And I love also cinema. It's a very big part of my life because, as I was telling someone before, I was initially not an engineer. I used to work for media and television, and then like 10 years ago, I started programming. And I also love reading books, so as you can imagine, I have also read some books about India. And I love food. I'm a foodie. So yesterday I had my good share of Indian food here at the hotel. And there you can have also my Twitter handle. So if you have any questions regarding the topic I'm speaking about, you can text me later on Twitter. I will also put the link to this talk, which by the way is here. So it's in slide.com, Gesteira/NG web widgets. Okay? But I will also post it on Twitter. So first, microfrontends. We have all heard about microfrontends, and they are famous because they allow having an application where we can have several frameworks at the same time running. But that's not what microfrontends are. That's not what the microfrontends architecture is about, and I'm going to try to explain about this. So I didn't know myself, so I went and asked ChatGPT, and he or she, whatever, I don't know, it's a robot, gave me a very extensive answer, which is very good, but on top of that, I had to investigate myself and test a lot of code because ChatGPT still fails a lot and has, I mean, it's not perfect. But it is very good to ask philosophical questions, actually, more than programming questions. So, microfrontends architecture, what is it about, right? It breaks up the front-end application into smaller parts, which we call microfrontends. Each microfrontend should be separately built and deployed. This is important. But also, and what makes a microfrontend is that it takes care of, no, this is not actually the thing, is that it can be handled, also not the thing, sorry. Sorry. It takes care of different UI. I was thinking about modules, not about microfrontends. And microfrontends can be handled by different squads. So microfrontends is actually about scaling teams, you know. Normally I wouldn't recommend to use microfrontends by default. I would enforce to use a framework, an application, and everything in the same framework, in the same technology. But, like it happened to me, it can come to a point that, well, you have some requirements, and you have to find a solution, and many times the microfrontends is a solution, not only because of technical reasons, but also because of political reasons at your company, or sometimes even logistic reasons, like for example, your team is growing up very big, or your project is growing up very big, or someone wants to use React, or whatever, and you need to scale a team, and maybe you can create a team with tribes and squads. And every squad is going to take care of a different microfrontend. But the misconception comes here. Many people think that microfrontends are always applications, and that is not true. That's what I'm going to show today. Microfrontends can perfectly be also components. And there's not only one way of doing microfrontends. As a matter of fact, we have been doing microfrontends for already quite a while. And we used to use iframes in the past, but iframes are evil. And why they are evil? Because they are very insecure. Because they are a target for something called cross-site scripting. So attackers or hackers find iframes very juicy. And then we have web components, which is a very good way of doing microfrontends. It's the way I recommend to do microfrontends, let's say. Microfrontends allow to create reusable custom elements. They contain also an encapsulated DOM called Shadow DOM, and that's the great benefit of web components. So styles from outside the web component will not interact, will not penetrate into the encapsulated Shadow DOM. And they are built with this kind of markup that actually looks very similar to Angular, because if you think of it, template is pretty much like ng template, and a slot is pretty much like ng content. And they need to be registered in the DOM by using the window global object custom elements .define. And with that method, we define a tag for the custom element, and then an HTML element, and then we wrap it into some wrapper element by using append child. So there is, of course, Lit and Stencil. They are both very good technologies to create web components. But since we are using Angular, and maybe one of the requirements in your project is that you have to be using Angular, we should use Angular elements. And Angular elements create microfronts in a different way. So what they do is they create a minimal self-contained version of the Angular framework, also of the Angular core, let's say, so that the web components can understand the Angular instructions. And so these instructions, such as, for example, change detection or data binding, have to be understood by the web component. So that's why it comes with this extra, let's say, core of the framework. And then there is a third approach to create microfrontends, and it's called the includes approach. And it can be both server-side or client-side, depending on who is the system who actually renders the HTML fragments, right? And this is exactly what Module Federation is using. That's the approach of Module Federation, because you may have heard about microfrontends actually more on Module Federation than on just web components. But actually many companies are using only web components and no Module Federation. And Module Federation doesn't have to be doing microfrontends. It can be anything. And I will explain why. So first of all, before I explain about Module Federation, let's understand what a module actually is. So you all know the script tag, right, in HTML. The script tag has a type attribute that by default is text JavaScript, which we are encouraged to leave empty, right, because it's default. And then there is another, which is called module, and it makes the script run in module mode. I will explain later what this is. And then there is a third type that I have to mention, which is import map. And this import map, which is beyond the scope of this talk, I will simply say that it's going to play a big role when implementing something called native module federation, which is going to replace Webpack's module federation. So what do I mean by module mode? What is that, right? So in JavaScript, we have different execution contexts, and we know them as scopes probably, right? So you may have heard about the global scope that runs when the script is running in script mode. But there are also three other local scopes. The first one is the function scope, and actually, if I'm not mistaken, in the past there were only like global scope and functional scope, and that was it. But now there are three local scopes. One is the function one, then there's the block scope for the variables, and then there is the module scope. So a module takes its own scope into play. So what's a module? It's a mechanism to split JavaScript programs, and the important thing is that it must contain important import and or export declarations. If it is not doing that, it's not a module. It must contain some sort of mechanism to import and export modules. And you can also name it like in the file with MJS, because even though JS extension and MJS extension are different, the execution of the script is totally the same, doesn't really matter. But you do it to signal that that file is actually an ES module. An ES module can run actually in native module mode, but non-ES modules cannot. Like for example, CommonJS, when you use them in Node.js with using this require keyword, these are not native ES modules. However, we can make them into that by using a building tool, and in our case is Webpack. This is going to change in the near future. We are going to use ESBuild, whatever, but for the moment it's Webpack. So now, module federation. Many people have asked me about this today, about module federation, so I will try to explain as clearly as possible. First of all, let's understand that it's a mental model. Today, many speakers have talked today about mental models, and there is a difference between a mental model and an architecture. So, module federation is not an architecture, it's a mental model, because it can take on different architectures. And as a matter of fact, module federation is inspired by GraphQL, because GraphQL takes supergraphs and subgraphs in the same way as module federation does, and module federation from Webpack is inspiring GraphQL's one. So the code is federated across different servers. That's important because those modules are loaded in runtime. And each part of the federation is a module, right? But there is one host module on top of the rest, and the rest of them are the children, which are called the remote modules. And any module can communicate with any module. So all the modules are omnidirectional in communication, meaning that the host module can communicate with the remotes, and vice versa, the remotes with the host module, and the remotes with each other can also communicate. So the circular dependencies are not only allowed, they are also encouraged. And this is the mental model of module federation. So as you can see, module federation is about this, and it's not an architecture, it's about something else. And this is the structure. This is the structure of the federation. And as you can see, it's very simple. We have the host, which I like to call the shell, and then you have different remotes. It can be one or several. And they import each other by using dynamic imports. And then there is one more agent, let's say, in this infrastructure called the remote entry.js. It's called like that by default, but you can use Webpack configurations to name this file differently. However, by convention, we call it the remote entry.js, which is not a module, okay? It's a manifest. And this manifest is actually what enables the dynamic sharing that I have spoken about and controls the module federation. And it includes, both references to all the rest of the modules that we have seen, the shell and the remotes, and also to the libraries that those modules are importing. And that's perhaps the biggest benefit of using module federation. So some considerations about the module federation. There are pros and cons. The pros is that there is no code duplication. This is something that I'm about to show you. When you use module federation with Webpack, Webpack by default has some caching strategies to avoid code duplication, so the same file is never loaded twice. However, with module federation, these caching strategies are refined up to a point that you can do it in much smaller chunks. Because, when you are doing, for example, an Angular application, you have the main, the polyfills, the rhyme time, JS, what's the one for the libraries, actually? Anyways, doesn't matter, but you have bigger chunks, and then the loaded strategies apply to those ones, and in this case you have much more fine-grained control over what is getting loaded and what is getting cached. And on top of that, you have not only that, but also control over the packages that you are importing statically in your modules. And also, you can even define what versions of those packages you want to be importing and which ones not. So it's quite amazing. And then, of course, like in every technology, there are cons. And the first one is that cross-framework is not guaranteed, and this is perhaps the biggest misconception about module federation. Whenever we think about module federation, and because we have seen other amazing talks by amazing people showing how module federation can enable this sort of multi-framework application, loading, one mini application on React, another on Vue, another on Solid.js, Svelte, whatever. This is not guaranteed. It depends pretty much on what is the shell, on what kind of framework we are using to create the application that is displayed in the shell. So the problem comes actually pretty much when using Angular as the shell, because this used to work before, but from Angular version 13, the multi-framework is not guaranteed. And I'm going to show how we can solve that, actually. And then, of course, when you are using module federation, every module, since it is compiled as an application, creates its own root scope, meaning you should never use the router module, for example, in these remote modules. It should be only used by what in Microfrontends architecture we know as the routing app, Because normally this shell host, module corresponds or is the same as the routing app, so the app that controls the rest of the apps. That's typically how it's structured, but it can be differently made, And in my case, let's talk about why I had problems, why I was in trouble, let's say. It's because my manager told me to. And I think we all have had this kind of situation where business people, overall business people come to us and request many weird ways, again because of sometimes political reasons, and in my case the requirements were, of course, you need to do it with Angular, because in my company the technology of choice is Angular, and I thought no problem, I love Angular, so that was really not the issue. Then you need to deploy self-contained HTML fragments. And then I thought of module federation automatically, because that's more or less what it does, right? But then they said, okay, but you don't have the routing app, and you will never have it. So before we have seen a talk about headless Angular with a headless CMS, right? The problem I had is we had actually a traditional CMS, and we needed some sort of universal web widgets where we could be able to display with Angular the shells, actually. So not, the thing is, we wouldn't have one shell and different remotes. We would have actually an unknown external application, and inside that, many shells with inside one remote. And that was kind of challenging. I didn't know if it was actually going to work, but when it did, I realized that I had built something that could work absolutely anywhere. And I mean anywhere. Well, that was me when I was in trouble, actually. But then this is the solution I came up to. We have mentioned that module federation doesn't guarantee a multi-framework application, so I really wanted to wrap the shells into web components, because that actually guarantees, because now they say they only want it with Angular, but who knows, right? Maybe in the future they say, let's do it in a different technology. So by wrapping or encapsulating the shell into a web component, you actually ensure that this is possible. And of course, then, like I said, you don't have one shell and several remotes. You have many shells, or as many shells as you want. Actually, in most of the pages that we are integrating this solution, it's only one web component with inside one shell and with inside one remote. But you have to make it scalable, right? So in the end, it can be that there are several. So let's take a look at the code. That's the GitHub repository for it. I don't know how much I will be able to show, but if you want, you can go and check it. I have left a lot of explanatory comments, so you will understand everything, but again, you can text me on Twitter if you need any extra explanation. So let's see. A ver. Sure. Okay. I'm very square, I have to be less organized. So let's take a look at the actual code. This is an Angular monorepo with 3 projects, okay? So the first one is the shell, then the microfrontends in plural, and then an external one which is not an Angular project, is not referenced in the angular.json. So both the shell and the microfrontends need to have some sort of Webpack configuration or extra Webpack configuration on top of the one that is currently used by the CLI. And in it, I have actually used this package that I recommend because this package by Andres Gesteira is quite good, it's quite nice, and it comes with some utilities that make your life a little easier when implementing module federation. So go for it. So you provide this extra Webpack configuration, and in the shell we say, okay, the public path for the shell is going to run in localhost 4200, but then you have to add also the module federation plugin, and this is not by Andres Gesteira, this is the actual module federation plugin by Webpack. And then you have to specify that you want that you want it to compile in modules, right? Like not in scripts, but in modules, as we have explained. And then you have to create a reference to the microfrontends. In this case, normally, you would have several references here, okay? Normally you would have a shell and different microfrontends, each one being one of those Angular applications in the repository. But in this case, I don't want to do that. And you know why? Because we have been working in this project for 6 months already, and we already have more than 100 components. Imagine having 100 micro-frontend applications here. It would be crazy, right? So we need to kind of engineer a way of having only one shell that actually grabs any kind of micro-frontend component that comes into it. Because like I said, micro-frontends do not need to be applications, can also be components like in here. And this is the reference to the remote entry.js file that needs to be loaded eagerly and not lazily, because it actually controls the module federation. And then we can specify here what packages are going to be shared. Actually, forgive me, because by default in module federation, all the packages you use are shared. However, you may want to specify the behavior of this sharing policy, let's say. And we are sharing the Angular core and the Angular common, because without any of those two, the components will not load, because all the components need a couple of things that are inside these packages. And we set singleton to true, because we want to have it in a consistent, so in the same Angular version all the time. Strict version to true. Everything is explained in the comments, but I don't have time to explain much. And we require version to auto, and that is establishing the range of the versions that are covered. And we are skipping secondary libraries, because by default, by importing one library, the sub-libraries will be also imported, and we don't need them, especially the development ones, like the testing ones. We don't need them. We don't even need the HTTP one, actually. But there are some HTTP capabilities that come actually in the Angular core that we do need at the start of the application. So that's the configuration for the shell. What about the configuration for the multiple micro-frontends, right? For the share thing, we have exactly the same configuration, so I'm just going to collapse it. And then, normally, like I said, you would only have one reference of one module or micro-frontend or application exposed here. But this is actually the way you can have multiple ones, and they are components. So typically, this would be only the app component of this concrete application, but this is not an application. And as a matter of fact, if you take a look at the source folder, you will see that I am naming it as lib and not as an app, because it is compiled as an app, but it's a library, it's a component library. Or that's how I have it in my project, you know. And then I created these 3 random components, you know, just to show how it works. And it's pretty much straightforward. The name is important, actually. This has to be coincidental with the name that you put in the other extra Webpack configuration. And this is probably not needed, but I have added it for clarification that the file name is remote-entry.js and not other name. All right? And then let's see what happens when we go to the shell project in the main.ts. Very simple, we need to asynchronously load the remote entry.js. If we don't do that, we might have a lot of problems. It is also possible to do it lazily, but not in this case, not in this particular use case. We need to load it in the beginning. So, what happens in the actual app component of the shell? We have a placeholder, as simple as that. I just wanted to show that. And then, in the actual component class, we register the web component. That's very important. So the first thing to do is in the constructor, we define the host. And this is basically using Angular elements to register a web component. That's what it does. And it needs an injector. So in this case, the injector of the app. And then in the ng-on-init lifecycle hook, we load the component asynchronously. I am using also here load remote module by Manfred Steyer's package because it works quite well. And then from the placeholder, from this placeholder, we can actually, and this is with the latest versions of Angular, it was not possible before. We can actually create a component with that module that we have asynchronously load, right? And on top of that, I have added some functionality so that that web component can take on web component attributes and can add them in an Angular way, but it will be a web component. And last but not least, let's see if all of it is true, if I have actually made it up or not. This project here, this external thing, is the most basic static HTML, CSS, and JavaScript that you can imagine, right? In here, there is no framework, there is nothing. So this is actually the proof that it can work anywhere, because I am just going to show you how it works in a static HTML. So I'm not even going to, well, here actually I have these 4200 and 4201 for shell and for microfrontends running. So those modules will be actually loaded asynchronously and are running in a server, because that's how microfrontends work. But this file here is totally static. So if I rebuild it in Finder and I just open it with Google Chrome, let's see what happens. A ver. Okay, this is something I did in the morning. I'm in the styles because I don't know, I wanted to be cool, and I cannot open the console now. Why not? It's the colors of the Indian flag, you know. Anyways, thank you so much. All right. So when it loads, I don't know why it doesn't work actually. Okay, I have to do everything with the mouse. It loads widget.js and then polyfills main and remote. Let's take a look again briefly, and I'm going to be finishing soon, at the HTML that I have put. There's some head here with the styles, and then there's a group of 3 buttons that load different microfrontends, the 3 microfronts that we have spoken about. And then here, there is a div with widgets, and this is a piece of HTML that your unknown application that belongs to an external company that you will never have control over is going to implement in a very similar way. They need to load the main.js file. And then I have added a script, you know, that actually loads the component asynchronously. And this here is the Angular component from the app component .ts that I have shown before. I call it the lonely component because nobody loves him. You know, now it pays attention to this component. What it does is basically it registers the web component, but it's not the actual component that is going to display anything. If we take a look at the elements, we will see that it's here. The ng widget there is an extra HTML tag with the ID host, and this is the lonely component. So what happens when we actually click on one of the Microfrontend buttons? Well, there is one first Microfrontend loading, and as you can see, there is the lonely component now has this ng version that is added in runtime by the Angular core, right? And then this is actually the web component that we have registered before. And as you can see, there is a shadow DOM because on top of that, actually, which I haven't shown, in the Microfrontends, if you go to lib, we have the containers here, and here the difference between container and presentational component is actually important, which always takes encapsulation to shadow DOM. It's pretty much recommended to do it like that because otherwise it's not fully a web component. Okay, and then we have loaded this component here, and then if we click here, we load the other one, and we click here and we load the other one. Okay, what happens if we click back to Microfrontend one, for example? Nothing happens, but it's still getting displayed, right? This is what I was talking about when I said one of the biggest benefits of module federation is that there is no code duplication, that the same thing doesn't get loaded twice, right? By default, like I said, Webpack does it, but in this case, as you have seen, we have a much more fine-grained control over it because there are many more chunks. There's one chunk for every module, and if we add children components, we would also have more JS files getting loaded, and they would never get loaded twice. And the remote entry here takes references to all the modules that are references to these numbers, right? So all these numbers here are modules that are getting loaded. So what happens, and this is another question that I got from people here, what happens if we have several instances of the same widget? Moment. So would this get loaded twice, or does it still get only loaded once? I have to reload because it's an static HTML, right? Moment. I have to do it with a mouse. I don't know why. Okay, so it's here. Here, sorry. And then, okay. And works exactly the same. Doesn't get loaded twice. So this actually works, and works like a charm, to be honest. Works without any problem. But to get to this kind of structure, you know, when you get the ng widget, it was really a hell. And there's one more thing that I would like to add to this presentation, apart from the actual explanation and demonstration of how it works, which is how do you create initializations on these container components that actually normally belong to applications? Because let's remember, now we are not loading application microfrontends. We are loading component microfrontends. So how do we do that, right? So we go again to the library and we take a look. In this case, we have this ng unit with some configurations that come from a service. So let's see what happens in the console. I reload again, sorry. Oh no, again with the mouse. All right. So the configurations are null, right? And this is because the configurations are getting initialized. Actually, I can show you, I think. Are getting initialized here, as you would do normally. This is the shell application. You would normally initialize the configurations here. You would load config for any, I don't know, API keys that you need. But this is using actually the root injector of the shell application and not of the children modules. So that's why in this case it's null. So how in the hell, how do we do that, right? So in the second component, I do the same, but getting it from the window. The good thing about module federation or microfrontends in general is that unlike, for example, when we were using iframes, all the modules are sharing the same window. So we can actually attach information to the window, and then that information would be shared in all of them. In all of the modules, doesn't matter if it's remote or if it is the shell. However, if you are going to work in different teams, I don't recommend polluting the global scope, the window object, with anything you want to put on it. You know, this would work, but it's not exactly what I recommend. So in my case, what I recommend, and with this I finish, I promise. I would recommend to use mixing classes. We have already spoken about the directive composition, but that will not do in this case, because directive composition doesn't remove the boilerplate. You have to reassign every property that you are composing. So it is very good for some things, and for the moment not for some others. I would recommend that you use a mixing class, and I finish. A mixing class to initialize anything. So if you actually, and this is the end, if you actually do that, you will get the configurations by doing it with a mixing class. So that's the end of the talk. Thank you so much for having me today. And yeah, thank you.
Thank you so much, Andres, for the amazing session.